Hello my friends, Sharky here. I just wanted to do a quick off-the-cuff video and get your guys' input. I got a question for you. I have a burning, fiery question. Water-cooled or air-cooled? Water-cooled or air-cooled? So I'm over here working on a palette kit for you guys. I'm testing out a new tune, trying to refine things, remove components so I can offer it at a cheaper price, just kind of finalizing it. And the question remains, water-cooled or air-cooled? So let me break down the situation from my perspective. Maybe you guys can make an informed decision and let me know. So basically what it boils down to between water-cooled and air-cooled is with water cooling, you can get more power. With air cooling, you can't get so much power. That's really the bottom line. Water cooling is more expensive. You have to buy fittings, hoses, radiators, and pumps. And of course, with air cooling, you got to get a fan too. So, that's kind of the same thing. With water cooling, all this stuff is pretty cheap. It's not terribly expensive, but it adds a certain level of complexity to your project, and I don't know if you guys are interested in that. Air-cooled is simple, It's hard to go wrong with it, but there are some other caveats. One of them is mounting the spreader and worrying about your temperatures. So, obviously not all heat sinks are going to be made equal, not all cabinets are going to be made equal, and you really got to pay attention when you're air cooling stuff that your junction temperatures on your device are going to be reasonable. And that's not something that the average Joe should have to worry about. So if you guys go out and get an ICA cabinet and mount this up in there, I don't have any data on that right now, so I can't say, oh hey, if you go buy this cabinet with this fan, you mount the heatsink this way and you purchase this heatsink, it's all going to work out. I don't have that data to provide for you guys. Whereas with water cooling, I can make up a parts list and say, hey, go get these fittings, this tubing, this, not actually this radiator, but I could say go get this radiator, this pump, and you'll be good. Continuous duty. You'll be able to have that with this water cooling, and you can have continuous duty with air cooling as well, but you're not going to get the power. You're not. So I'm over here doing some calculations, and basically what it all boils down to is the heat dissipation in the device. If you want more power, you're going to have to suffer more power dissipation, which means the device is going to get hotter, which means you have to cool it better. If you don't, the device blows up. Ask me how I know. You guys have seen my drawer of dead LD Moss, right? This is something I've analyzed quite heavily, and basically what it boils down to is this palette. I've been working on this for a little while, getting it tuned, getting it kind of optimized as far as price and components go, so that I can offer it at a better price and still get really good harmonic performance, power output, all that good stuff. Basically what it boils down to is I could take this palette, slap it on an air-cooled heatsink, and be okay at lower power levels. So for example, if I were to take this same palette, run it at 50 volts, you could put this thing into just about any ICA cabinet with a decent fan and be okay as far as temperatures go. Now the caveat to running it at 50 volts is you're only going to get 1400 watts peak. You might be able to drive it a little farther than that, but if you do, your waveform's going to get nasty. And I'm sure you guys are interested in this stuff because you want the best. You want good linearity. You want good what's the word I'm looking? Good distortion characteristics, good linearity, good durability, all that stuff. That's why you get LD Moss, is for those characteristics. If you don't care what your signal looks like on the scope, go buy a 2879. Drive your shit into compression. Nobody cares. But anywho, at 50 volts, this will run air-cooled all day long. Now, if we step that up to 57.5 volts, we're going to get more power. but we're also going to get significantly more power dissipation. So this is just a little cheat sheet of mine. This is all the 500 watt dissipation numbers, the 600 watt dissipation numbers, and these are my actual numbers. So this pallet right here at 57.5 volts, it runs great, but it dissipates a little more power, somewhere in the 600 to 700 watt range. And that's, in my opinion, it's too much for your typical air-cooled cabinet. If you were to try and dissipate 600 or 700 watts with an LDMOS device in a typical ICA cabinet, you're not going to be continuous duty. You're going to have to monitor that key down time. You're going to have to be real careful about that. And then once you get up to 65 volts, you're way past air cooling and you're into water cooling. You're into high performance water cooling. Like once you get this thing up to 65 volts, you're in the serious water cooling. You really have to have the right heat sink. You have to have the right radiator, the right fans, the right pump. And like I said, I can provide you guys with all that information. But what do you want to do? What do you think? You push this up to 65 volts, you get 2K peak, no problem. But you got to deal with the water cooling. So another factor to consider is that water cooling. If I were to water cool a pallet, it would come with a water block, just like the ones that I've showed you before. And it would actually be pretty easy to mount the whole pallet into a cabinet. You wouldn't even need a heat sink of any kind. What I could do is I could make kind of a sacrificial mounting plate out of printed circuit board material that would go on the bottom. And it would, just have some flanges on there, so you could just, punch a hole in it and mount it with a screw and do that 4 times around it and call it a day. Mounting it for water cooling would be really easy. Water cooling components are also really easy to mount. All these heat sinks are for 120 millimeter fans. All the ICA cabinets have holes for 120 fans. To mount your water pump, it's 4 holes, 4 screws, you're done. With air cooling, you have to drill and tap a piece of metal at least 4 times to get good contact with the heatsink. There's these 4 holes. These will probably be M6 screws, 1/4 inch for those of you guys that don't understand metric, 1/4 inch screws. And then you got to mount these screws as well. You'd have to drill and tap those into your heatsink, and those are either 440s or 3mm by 0.5s. There's a little tiny screws and little tiny drill bits and little tiny taps, and it's a whole nother process that you have to go through. And you have to risk breaking taps and risk breaking a drill bit and risk drilling a hole in the wrong place. And there's upsides and downsides all around. So I don't really want to make 2 versions of this. I really, really don't. My manufacturing costs, it goes up. I make these spreaders. I machine them. I program the machine that machines them. I put them in the machine. I press the start button. I take them out of the machine. Same thing with these water blocks. I make all that. And I just want to offer you guys a product at a reasonable price, and I want you guys to be successful. That's my goal here. I want you guys to be successful. Oh, while we're talking about the pros and cons of things, let's talk about the pros and cons of running at 50 volts versus 65 volts. So we've already established more volts, more power, right? That's definitely true. More volts, more heat. More volts, more power. Less volts, less heat. Less volts, less power. One thing I probably haven't mentioned in any of my videos before is how hard it is to get your hands on a 65 volt power supply. I had to go all the way to China to get this one. Not literally, but you get my meaning. And it's a switcher. It's a Chinese switcher at that, so the power coming in is not filtered and the power going out is not filtered, which means that it's going to put switching noise back into your power supply and all through the wires in your house, and it's going to put switching noise all through these wires into your pallet. So this piece of crap is very, very noisy. My bigger ones use the same switching supplies in them, and they're also very noisy. I spent a lot of time getting those filtered down to a manageable level. Still not perfect, but manageable. And I went with this one because I could not find a power supply that would give me 40 amps and 65 volts anywhere else for a reasonable price. Now, 48 volt supplies or 50 volt supplies, on the other hand, are commonplace, man. You can get those things all over. You can get the ESP 120 supplies for, I don't know, I bought mine for 50 bucks. And those things are like 65 amps, 50 volts. They're monster supplies. I mean, they have their own issues, you know, they're weird shape and they don't have, you know, it's not easy to connect them. It's hard to put them in a chassis, and you really kind of have to put them in a chassis because they have all these exposed connections. You know, that's another pro and con, is the power supply to get you up to 65 volts. So bear all that in mind and tell me what you think. Would you rather have a water-cooled pallet or an air-cooled pallet? Water-cooled pallet, you can go, man. You can go for days. You can run it continuous duty at full power at 65 volts, 2 kilowatts, no problem. Air-cooled, you probably get 1600 watts before you really start screwing up your continuous duty and start having to monitor your key down times. But yeah, you know, is what it is. I think I've explained my position. You guys jump down in the comments, let me know. I am Mud Duck Sharky, and I hope you enjoyed my off-the-cuff video and my disastrous desk right now. But I'll be back with another video very soon. Thanks for watching.